pause the video and reread the question if you haven't done so already. In this question, we are asked to find the derivative of a given function using the definition of the derivative, and then to state the domain of both the function and its derivative. So why don't we go ahead and take a look at the definition of the derivative. Perhaps a bit of an intimidating expression, but not too bad once you go through with it. What we're going to do is take the quantity x plus h, and we're going to plug it in for each x in the function, and then we're going to subtract the original function and simplify, as you'll see. So let's go ahead and get it started. And I'd like to point out just a couple of things. First of all, you'll notice we've color-coded x plus h in red, just in order to help make it stand out and make it appear different than f of x. We'll also notice that we've enclosed f of x in a set of brackets, and that's going to encourage or remind us to distribute the negative sign to all of the terms of f of x. If we don't do that, then the problem actually will not be solved correctly. So what we'll do next is we'll simplify the x plus h squared by writing it as x plus h times x plus h. And after writing x plus h in that manner, we can go ahead and we can FOIL. And if you have any questions about the precise nature of the foiling, please let me know in the comments. But we'll go ahead and FOIL that. We'll also distribute the minus sign into each set of parentheses. So right there, and also right here. So we'll take a look. And then we'll also, in continuing to clean this expression up, distribute the 1.5 to all three terms in this set of parentheses. So after all is said and done, it'll look like this. And now we come to what I consider to be the most fun part of this problem, and that is the canceling of opposite terms. So we'll notice in the numerator that we have a positive 1.5x squared and a negative 1.5x squared. We have a minus x term and a plus x term. And finally, we have a plus 3.7 and a minus 3.7. So we can go ahead and cancel all of those opposite terms, leaving us with an even more simplified expression. We'll then next notice that each term in the numerator has at least one factor of h. And since each term has such a factor, we can place that h on the outside, or in other words, factor it out. So if we do so, that will turn the expression into the following. And then, of course, when we have a factor of h in the numerator and a factor of h in the denominator, we can cancel those factors, leaving us with following. And it is at this point in the problem that we can finally plug 0 in for h, because there is no longer an h in the denominator. And so if we do so, we have the following. Notice we no longer have to write the limit as h approaches 0, because we are finally allowing h to become 0. And this expression will simplify to the final answer of 3x minus 1, which is the derivative of the original function. We'll notice that both the derivative 3x minus 1 and the original function, which was 1.5x squared minus x plus 3.7, they are both polynomials. One of them happens to be a parabola, the original function f of x. The other polynomial happens to be a straight line. And we know from pre-calculus knowledge that the domain of a parabola and the domain of a straight line is all real numbers. So that will be the domain for f of x and for f prime of x. The domain for each will be all real numbers, which we can write in interval notation as negative infinity to positive infinity.